Perfect. Welcome, everyone. My name is Taylor Ward, she, her, and I am the Communications and Education Manager with Just Solutions. And I'm calling in from Seminole and Muscogee Land, otherwise known as Tampa, Florida. For those who don't know, Just Solutions identifies and promotes just solutions to climate change for Black, Indigenous, Latinx, Asian, and frontline diasporas. We provide informed analysis, reports, and more on the just solutions for an energy future that supports the replication of community-developed, equitable, and just solutions. Thank you so much for joining us for today's webinar on carbon capture and storage and what it means for environmental justice. As I mentioned, if you're just joining us, feel free to add your name, your organization, and your location in the chat so all can know who's on the call with us today. In today's event, we will hear from Just Solutions staff experts on the basics of CCS and understand its impacts on EJ communities. We will explore how CCS fits into the current conversation around federal funding. And this webinar is part one of our CCS series this year. We'll be exploring this technology and its impact on our communities. The goal of the webinar today is to inform our audience about the fundamentals of CCS and ways that it may impact their community. So if you have any questions or concerns about the content of our webinar today, please feel free to email me, which I will share in the chat, but my email is taylor@justsolutionscollective.org. So in terms of our agenda, today we will have a presentation from Arjun Makajani about the technical fundamentals of CCS, and then a presentation from Sylvia Chi about the federal funding landscape and how CCS fits into this. We will also have time for audience Q&A, so if you have questions throughout the webinar, feel free to drop your questions in the chat or use the Q&A chat box feature to share your questions with us. So to introduce our speakers, first we will hear from Arjun Makajani, the president of the Institute for Energy and Environmental Research and an energy expert with Just Solutions. Arjun has a PhD from the Department of Electrical Engineering and Computer Sciences at UC Berkeley and is a recognized authority on energy and an author of numerous reports and books on energy and environment-related issues. We will then hear from Sylvia Chi, who is the Senior Policy Analyst at Just Solutions, working on federal policies and financing. Sylvia currently leads on policy advocacy and implementation of the California Public Banking Alliance and was a principal co-author of AB 857 in 2019, which established a licensing framework for public banks in California. Sylvia earned her JD from the University of Maryland School of Law and AB from Dartmouth College. And with that, I will turn it over to Arjun to get us started today. So Arjun, feel free to share your screen.
Give me a second. And there. Oh, doesn't want to go full screen. Can I run through like this, Taylor? Do you mind?
Can you zoom in a little bit?
Stubborn and not going full screen.
Can you zoom in on it?
There.
Perfect.
Okay, is that good?
Yeah.
All right. I'm going to give you some technical basics and some perspective for CCS on climate. What is it? Do we need it? In that order. Broadly, I think there are two kinds of groups, some overlap that look to carbon capture and sequestration. One is the fossil fuel industry. They have a vested interest. It may perpetuate fossil fuel use. They claim it might be compatible with climate mitigation. And then there's a climate view, we're already over the top with CO2 concentrations. Should we do CCS and how should we do it and so on. They have very different implications for climate protection. That's something I want to explain why it is very different, these two ideas to a large extent. And in this and all other climate things, my one of the technical fundamentals is methane, as you know, is very powerful as a greenhouse gas. Its half-life in the atmosphere is about 9 years. So it loses most of its impact in 25, 30 years. And our climate crisis is 20 years. 30 years, we need to look in that time frame to mitigate most of the impacts of what we're doing by emissions. And so it's very central to use a 20-year warming potential for methane compared to carbon dioxide, and also very central to use realistic methane leaks, official leaks, as you probably all know this. I'm just saying because very central to the calculations that I'll show you. And the thing is CCUS, so carbon capture could be used or sequestered. Sometimes there's some overlap in those terms too. So what is it? So this is a natural gas power plant, typical. It has a gas turbine here. It has a heat recovery and a steam turbine. This is called a combined cycle plant, gas turbine and steam turbine. And here's the CO2 capture. So the off gases from here will contain carbon dioxide, oxygen, nitrogen, and also some pollutants. And then you want to capture the CO2 here. The rest of the gases go there. You compress CO2, you use it, sequester it. Here's what it looks like. I'm sorry for the complexity of this. I could not find copyright-free chart that was simpler. But here's the essential. This is where, to the left, this flue gas, that's where the carbon dioxide gas would come from. The flue gas is from the power plant or from hydrogen production. And then it would go into this chamber. This is where the carbon dioxide gets captured, where that yellow arrow is going, yellow and black arrow. And there's a solution an amine solution, which is amine is an ammonia-based organic compound. I pronounce it amine. Some say, I don't know. I'll say amine. In accord with other people's pronunciation. And so the gas goes from the bottom, and the amine solution is put into bubble, drips through this chamber. It's a very long chamber with baffles in it. And then that solution captures the carbon dioxide, and then the carbon dioxide rich solvent falls this, you see rich solvent, and then it goes into this other chamber. This other chamber has heat, steam, and that steam kind of strips the carbon dioxide here that is cooled and condensed, and then the carbon dioxide, what you see, the product. So it's basically capture the carbon dioxide with a solvent, recover the solvent by stripping the carbon dioxide and capturing it, and then you recycle the solvent. It's not perfect, of course, you don't have 100% recycling, but that's the idea. It takes energy to do this. It takes more energy to produce the power. It takes energy to run this. It takes energy to heat up the amine chemical to strip the carbon dioxide. And that's why when you do, say, power production with CCS, it takes more energy than just doing power production. That energy in a natural gas plant would come typically from natural gas. For the heat there, where you burn it, and then more energy for the power production. You need electricity for compression. You need to pipe it to wherever it's going to be used under high pressure, and so on. This is what it looks like. This is the government's carbon sequestration experiment station, large-scale experiment. Looks a lot like a refinery. That's why it was sort of like this. A refinery flow chart might look like that too. This technology is actually used in the petrochemical industry in order to strip natural gas when it comes from the earth. It comes with some hydrogen sulfide and carbon dioxide. And this the same technology basically is used to clean up the natural gas before it's put in pipelines for use. Otherwise, you get hydrogen sulfide in the gas that comes into people's homes and businesses. So I did some calculation as to so the two major uses of CCS that are talked about are natural gas power production with CCS, so that natural gas can go on being used and be called clean power production, quote unquote. And then the other is very similar. Today, we produce hydrogen from natural gas. It's called steam methane reforming, SMR. It's actually the same acronym as a small modular nuclear reactor, but SMR, steam methane reforming for today. So on the left, the blue part you see of 339 grams per kilowatt hour is the direct emissions of carbon dioxide from in a fairly efficient natural gas power plant, and 262 is, as you can see, if you don't use realistic methane leaks, this 262 would be divided by 3 for the approximately 2.5 for the global warming potential, and divided by 2 for low estimates of leaks. So about a factor of 5 or 6 less. So instead of 260, you just have 50. But this is a pretty realistic estimate, 300 for about 600 grams per kilowatt hour of CO2 equivalent, 20-year time frame. Now, what happens when you do CCS, carbon capture, is you're capturing 90% of this, but now this 339, but now you're using more natural gas. You have to generate more electricity. So you have about 15–20% more electricity. And so this 339 actually goes to 460. You capture 90% of that. Pretty typical. That's been tested. Some people say you can do 95 or plus percent, but then that takes more money, more equipment, and more energy. But what you don't do is you don't get rid of the methane leaks. Now you're using more natural gas and you have more methane leaks. So overall, after all that trouble and raising the price of electricity, you've eliminated about 85% of the CO2, but only about 35% of the total carbon dioxide equivalent 20-year time frame. That's why that is so central to everything. We have to insist on it, not because we're ideological, but because that's the realistic timescale of climate protection. These numbers would be very similar if you applied it to hydrogen production from steam methane reforming natural gas, as it is done today, and then you apply CCS to that, you don't get rid of the leaks. Now, we have a Biden administration proposal to reduce methane leaks. It's by 30% in the next 12 years. It's not going to solve the majority of this problem. It's too slow and too little. We need to increase the ambition of that. You have some collateral damage by doing this because amine solutions are nitrogen-based solutions. You increase nitrate water pollution. You double your nitrogen oxide emissions relative to no CCS. You double the water withdrawal. These numbers are from the Department of Energy. The slides do have the link to that DOE National Energy Technology Lab report. There are possible CO2 leaks from pipelines. Of course, the pipelines could also explode. It's happened. There are leaks potentially in the disposal area. There's a roughly the cost of power at the natural gas power plant would increase about roughly 50%, give or take. This hasn't been done at scale and repeatedly, so these are rough estimates. I think not inaccurate. Some carbon capture could be done better, but this is the standard technology that is sort of pretty commercial today, as I said, because it's pretty much used in the natural gas production. The other kind of carbon capture and sequestration is called direct capture. So you burn natural gas in a power plant, you make hydrogen, you burn natural gas at home, in buildings for heating, and then it's in the atmosphere, about 400 odd parts per million, and then you take it out. They're giant blowers and you run it through the amine solution. So the idea is basically the same, but it takes a lot more energy. Now you have, instead of 3, 4, 5, 10, 20% carbon dioxide in your flue gas, you have 0.04%. That's 400 parts per million. I think that's right. And then, so it takes a lot of solution, a lot of energy, a lot of heat. So you need a lot of electricity, about 1,200 kilowatt hours per metric ton. So if you're capturing 1 metric ton, with today's electricity grid, national average. You'll be using, emitting about 0.5 metric ton just in the electricity generation. Then you'll be having more methane leaks from your electricity generation because about 40% comes from natural gas electricity production. Then you use natural gas for that amine heating, the stripping. There's natural gas leaks associated with that. So you captured 1 ton, but the net CO2 equivalent, if you use the national grid today, will only be 5% of that. Not worth it, in my opinion. I don't know that I have not seen this same calculation, especially for you, done in the last, or especially for this webinar. Now let me turn, so as you know, most carbon capture is just used whenever it is used. It is used for petroleum production. So we're trying to get rid of fossil fuels, and people who worry about climate more than fossil fuel profit think it's a bad idea, and I agree. But there are some uses that sort of combine sequestration with use. This is a technology that is being developed in Canada. This is an actual concrete block that is made out of steel production waste, slag, and running carbon dioxide through slag for 24 hours and obviously pressing it into a concrete block. This is very similar to the concrete blocks. So this basically traps the carbon dioxide in the block. Now it's part of the block. You have displaced not only the carbon dioxide that would be used to make this. That's a sort of one-on-one trade-off if you do it with today's carbon capture. But your cement takes limestone, and more than half, if I'm not mistaken, of cement's emissions come from converting limestone, calcium carbonate, into calcium oxide, lime, which is central to cement performance. So now you've gotten rid of that lime. And of course, if you do carbon capture with renewable energy, you save a lot, you lock up a lot of carbon, and you displace a lot of cement. Could be important. An example of carbon capture and use that's not petroleum production that could be good. But on first sight, at least it looks good. Do we need CCU? So this is from the IPCC report. This is the net temperature. This is from 2 years ago. We're 0.1 degree already more than this. But the net temperature, net warming consists of a warming aspect, this bar, the taller bar, 1.5. And then there's cooling from sulfate particles and there are other details on the right here. You'll get these slides, or at least they'll be on the website and in the recording. The net is, we have a 0.4 degree cooling impact, as it says here in the chart itself, that about 0.4 degrees of heating is being masked by these cooling impacts, mainly sulfur dioxide. Now that sulfur dioxide will largely go away when we get rid of coal, and we want to get rid of coal. So basically, in terms of greenhouse gas forcing, we're already at 1.5. And of course, we're continuing to emit methane and carbon dioxide. So the short answer is we need to reduce the climate forcing drivers. Carbon dioxide is the biggest one, but you can see methane is pretty close up there, and there are others. My take on this is that it's much more important for now and the next 2 decades to reduce methane emissions and try to eliminate the methane in the atmosphere. Methane's lifetime is short, so if you stop abusing Mother Nature will forgive you, and the methane we already emitted and accumulated due to our activities will go away in about 30 to 40 years. That's not true with carbon dioxide. It's going to stay there for hundreds of years. It's similarly with the refrigerants that we use for refrigerators and car air conditioners and so on. So these are my conclusions. We need to eliminate fossil fuel first. Burning them and capturing them, as you can see, is a losing proposition, plus causes a lot of other damage. And a lot of that damage, of course, will be in environmental justice communities. CCS has many negatives, and the biggest uses proposed now are natural gas power production and hydrogen, so we can have clean hydrogen and clean natural gas power production. I don't think so. We need to focus reducing concentrations, at least now and urgently, on methane and these refrigerants. There are some other minor things I won't get into. Nature-based CO2 removal, most of you know of it. The calculations on this are very complicated, very difficult, but nature-based solutions should be preferred. Working with the rhythms of nature, I've written some blogs about it. Some carbon capture and use may make sense. I've given you one very important example. Carbon can also be used to cure concrete. Carbon dioxide can be used to cure concrete. It's being done in New York City in a tall building recently as a pilot. Now, are we going to need carbon capture and use or sequestration of the type I've talked about? Well, it may make sense only if you have a fossil fuel free or close to that energy system. We're continuing to emit CO2. We may need it. We are in a deep hole. How we dig out of the deep hole isn't quite clear fully, but we know the big elements of it. And the short of it is CCS, as it's being proposed, is not for now. CCS air capture might be developed in a more sensible way. There might be some uses for it. Mostly it's very problematic and does not at all correspond to the scale of investment. So I'll pass it to Sylvia. We need to be doing other things with that money. And Sylvia will tell me how much we're using. I'll stop sharing. Thank you very much.
Thanks so much, Arjun. That was great. And I will pass it on to Sylvia now.
Okay, just give me 1 minute while I get my slides up. Okay. Okay, I think that is up. Let me know if you don't see it.
We can see it.
Okay, great. So I'm just going to give a overview of the federal policy landscape on CCS and try to highlight what EJ folks need to know about it. So let's start with a kind of history and context. Basically, the federal government started getting into support of CCS starting in the 2000s and mostly in the 2005 Energy Policy Act. And that's where Congress first authorized DOE to begin research and development on capturing CO2. I think that was about was $90 million that they first started the R&D with. And R&D in DOE has continued since then, and they've expanded the scope of the program over the years. For example, in the 2007 Energy Independence and Security Act, and overall in regular appropriations from 2009 to 2021, Congress has appropriated $2.7 billion for these activities. In 2008, Congress created the 45Q tax credit for CCS, and we'll get into this in more detail in a little bit, but basically this creates, this gives money to companies that based on the amount of CO2 that they use or store. And that credit was created in 2008 and it was later expanded and extended a few more times, most recently in the Inflation Reduction Act. And then in 2009, in the American Recovery and Reinvestment Act, Congress provided $3.4 billion, mostly for demonstration projects. And of that 3.4 billion, 1 billion was never spent. I don't get into this in detail in this presentation, but there's some good information out there about the record of those projects, and basically they didn't go very well overall. And then in the Infrastructure Investment and Jobs Act, which is also known as the Bipartisan Infrastructure Law that was passed in 2021, Congress really upped their support by providing $8.5 billion for various CCS programs. And those programs expanded the scope even more to include new focuses on transport, storage, large-scale pilot programs and demonstration projects. And that's not even counting another 3.6 billion that's specifically for direct air capture. And then more recently, in February 2022, the White House Council on Environmental Quality published their interim carbon capture, utilization, and sequestration guidance. They also had published a report about basically they're thinking about how their administration is going to approach this issue. And then, like I mentioned already, the Inflation Reduction Act of 2022 was passed in August, and that amended and extended the 45Q tax credit for CCS. So that's basically where we are today in terms of the federal policy landscape. And I think in general, I think we should just know that the Biden administration is all in on CCS. They've used this language multiple times about how they think that in order to reach their domestic climate goal of net zero emissions economy-wide by 2050, they will likely have to capture, transport, and permanently sequester significant quantities of carbon dioxide. And so they think it's important to do to support research, development, deployment. They're very invested in this tax credit, but they also talk about how they think it's important to implement the robust and effective regulatory regime in the US and ensuring that these technologies are informed by community perspectives and are consistent with the administration's climate, public health, and economic goals. So I highlighted those pieces about the regulatory regime and the community perspectives as just like themes that we can use as leverage when we're trying to push back on the more harmful ways that these policies are being implemented. So I'm just going to walk through a few of the programs that are in the infrastructure law and then also the tax credits. This is not meant to be comprehensive, so it's just a few examples, but it's pretty, they exemplify like the overall programs. So one of the programs in the infrastructure law is the carbon capture demonstration projects. And this is funding for 6 projects that are supposed to demonstrate substantial improvements in the efficiency, effectiveness, cost, and environmental performance of carbon capture technologies. And they want to have 2 of these projects on new or existing coal power plants, 2 on new or existing natural gas power plants, and 2 at new or existing industrial facilities that aren't power plants. And they want these to be commercial scale, so they're supposed to be integrated with a commercial facility. And they're asking for these projects to show that they can do at least 90% CO2 capture efficiency over baseline emissions, and that they're on a path to achieve even greater CO2 capture efficiencies. And they need to be able to show that as part of their application and then throughout the award. And then there's also a 50% federal cost share, which means that the applicant has to pay for 50% and the federal government pays for the other 50%. This is listed as a Justice 40 covered program. And I think probably a lot of folks on this call have heard of Justice 40. That's an initiative by the Biden administration to provide 40% of the benefits of specific programs to disadvantaged communities. We will have more information about Justice 40 going forward. I just wanted to highlight this so that folks know. I think it could be used by local communities as a way to make sure that their voices are heard, because DOE's Justice 40 general guidance does require that covered programs, Justice 40 covered programs, have community benefit plans and stakeholder engagement plans. So there's at least the argument to be made that when they work on these projects, when they develop them, there needs to be community input involved. So this program is currently accepting letters of intent from potential applicants through the end of this month, and then the full application deadline is in May. So we don't know yet where these projects will be. There's no like centralized place where we can look and see where all these projects are, and we'll just have to keep watching to see who ends up applying. Another important program in the infrastructure law is the Carbon Dioxide Transportation Infrastructure Finance and Innovation Program, which had $2.1 billion appropriated to it. And this is a loan program or financing program. So they're going to use the $2.1 billion and leverage it so that it has a greater effect. I don't know exactly, we don't know the details of like how the loan program will work, but it will be more than 2.1 billion. And the idea is that they will provide low interest loans for companies that are building the CO2 transportation infrastructure, which basically means pipelines. And they have identified these requirements for eligible projects. It has to be a large capacity common carrier. That means it can't be just like one pipeline that's from like one company's facility to like their other facility. It has to be open to like multiple companies to use. It also has to have demonstrated demand for the use of the infrastructure. And I think that's probably going to be the main obstacle in terms of the timeliness of this program. And then it has to enable geographical diversity in the projects. So that just means they don't want all of the pipelines in one place. And then they also want these to be sited within or adjacent to existing pipeline or other linear infrastructure corridors in a manner that minimizes environmental disturbance and other siting concerns, which suggests that they want to reuse existing pipelines or otherwise put pipelines in places where similar things already exist. And again, this is another Justice 40 covered program, so just keep that in mind. The status of this one is they have not started it yet, and the estimated application opening date has already passed. So we will just keep on tracking that. There's another important program in the infrastructure law that I wanted to highlight, the underground injection control grants for Class 6 wells. This provides $25 million to EPA to permit Class 6 wells, and then $50 million to states to apply to EPA for primacy to permit Class 6 wells. And primacy here just means the state authority to do it themselves. In some other contexts, we call it like delegating authority, but for some reason that I'm not familiar with, we call it primacy in this context. Basically, this is like, you know, how EPA often allows states to do some of the regulating themselves. for different kinds of programs rather than EPA directly regulating it. Anyways, so class 6 wells are basically holes in the ground that are used to inject carbon dioxide into deep rock formations, and this is called geologic sequestration. And this is conducted under the Safe Drinking Water Act. So there's other types, the other classes of wells include the kinds of wells that you drill to get water. Also, separate program, but related, the Department of Interior under the infrastructure law was instructed to develop regulations to permit leases on the outer continental shelf for sequestration. And their draft regulations are expected to be released by November of this year. And they're looking at sequestering carbon in depleted oil and gas wells. And then this is a map of the current state for class 6 well permitting. There are only 2 EPA permitted wells currently, and those are at an Archer's Daniels Midland ADM ethanol plant in Illinois. And those were permitted back in like 2014. And since then, EPA has not permitted any new ones. And then there are 2 states that already had primacy to permit their own wells, and those are North Dakota and Wyoming. And those they got those. I think Wyoming was in 2020. So those both happened before the infrastructure law. But since the infrastructure law, there are 4 states that are already in the pre-application phase for primacy. And then there are at least these 4 other states, Montana, New Mexico, Kansas, and Oklahoma. All right, no, those are the ones who are, yeah, those are the ones who are considering seeking primacy. And this is just from information that I found, online. There could be other states that are also considering seeking primacy that I haven't picked up on yet. Oh, and one reason that I'm pointing this out is that if you're in one of these states that is considering seeking primacy or is already in the process, that means that you have the opportunity to intervene at the state level and see what you can do there. Because one argument that the advocates for CCS are making about primacy is that when states have primacy, they can do it in a more streamlined manner, because they're pointing to how slowly EPA is working on permitting the states, the wells themselves. EPA has a list of maybe like 12 other wells that have applied for permits that have been pending for years. So they think that the states that want CCS can push it through really quickly. Okay, so the other piece that's really important in terms of federal policy support for CCS are the tax credits. So like I mentioned, the IRA extended and expanded and increased the 45Q tax credit, and they're expecting, their estimate is that $3.2 billion in tax credits will go to CCS over the next 10 years. And the credit amounts are increased from what they used to be. The structure is a little complicated, but if the projects meet the prevailing wage and apprenticeship requirements, then it's $85 per ton for CO2 that's permanently stored, and then $60 per ton for CO2 that's used for enhanced oil recovery or other industrial uses if life cycle emissions reductions can be clearly demonstrated. And then they have even higher amounts for direct air capture. And this applies to facilities where construction begins before January 1st, 2033. So currently the law contemplates that the credit will go away after 2033, but we've seen in the past that they keep extending it, so that's also a possibility to keep in mind. In the IRA changes to the credit, they made stricter thresholds for the amounts of carbon captured. So they're saying if you have a direct air capture facility, the facility has to capture 1,000 metric tons per year in order to be eligible for this credit. And then for power plants, it's 18,750 metric tons and a capture design capacity of at least 75% of baseline carbon production. And then other facilities, meaning industrial facilities, 12,000, the threshold is 12,500 metric tons. And then another important provision is that they're making direct pay available on this credit, including to corporations. And that means that instead of the normal process for getting a tax credit, which is that when you file your taxes with the government, you usually you have a liability, and then like you owe the government $500, and then you also claim a tax credit for say $100, and then that means you only pay $400. In the case of direct pay, you fill out a form. We don't know the process yet. They haven't finished that process. But basically you fill out a form, send it to the government, and then they just send you the money directly. So you don't have to wait for the time when you file for your taxes. And it also means that you don't necessarily have to have a tax liability to get the credit. For other types of tax credits, they've made direct pay available for nonprofits and state and local governments, but not corporations. But for this credit, as well as the credit for hydrogen, they have made this direct pay process available for corporations. So that just shows how they're really prioritizing this as a way to support the CCS industry. And then also as important context, as I said, this credit has been around since 2008. In 2020, the Inspector General for the Treasury Department found that in the last decade, 87% of the $1 billion in tax credits that have been claimed went to facilities that are not in compliance with EPA's monitoring, reporting, and verification requirements. And this was not addressed in the Inflation Reduction Act. So that is a concern, I would say, about going forward with this credit. So one last thing to mention about the federal policy landscape is the upcoming carbon standards for fossil fuel power plants. You may have heard of West Virginia versus EPA, which was a big Supreme Court case last year where the Supreme Court struck down some Obama-era regulations for greenhouse gas emissions from power plants. Those rules were never in effect, but they struck them down nonetheless. And EPA has been working on new regulations. So these are basically greenhouse gas emission standards for fossil fueled power plants. And based on what the Supreme Court said in their opinion in West Virginia, they were very skeptical of controls or requirements that are called beyond the fence line. So they indicated that they were more likely to support standards or allow standards that look more conventional, like equipment that you put on the end of a smokestack. So that's one reason that a lot of people think that a CCS-based standard is likely to be incorporated into these new rules. As context, EPA, like when they were developing the original Clean Power Plan rules, they considered requiring CCS, but rejected it as too costly. Of course, now the market is different and the subsidies for CCS are much stronger than they were then. And we also know that EPA released a white paper last year on natural gas turbines and CCS, which kind of suggests that that's what they're looking, that the direction they're going in. Arjun already talked a lot about the problems with kind of continuing to use natural gas in this way. I think it's important to keep in mind that it just would continue to enable health harming pollution all along the supply chain, not just at the power plant. And then another important thing to keep in mind is that if these standards do come out, there's different rules that apply to new power plants and existing power plants. And at least for the existing power plants, there is some flexibility for states to adopt different plans. So they wouldn't necessarily have to require CCS for existing power plants if that's what comes out in these new rules. And we are expecting those new rules to come out in draft form as soon as next month. So stay tuned. Okay, so that is the end of my section. And so I will stop sharing and we'll move on to Q&A.
Awesome. Thanks, Sylvia, and thanks, Arjun, for your great presentations and setting that context for us. So yeah, let's dive into some questions. So this question is, the first one's for you, Arjun. Some folks had questions around the use of CO2 in the concrete blocks. Do you see any issues with CO2 escaping from those blocks? You mentioned that this is also being piloted in New York, using them to build buildings. So yeah, any of your thoughts on that question?
Now, I'm not a concrete expert, so caveat, but to the best of my understanding, the CO2 actually becomes bound up with the cement. So it becomes part of the block. So it's part of the chemical structure of the block. So unlikely, I don't know what happens when the concrete crumbles, but I don't think so. So it is a manner of actually sequestering carbon while also carbon dioxide while also using estimate.
Awesome. Thank you for that. And then for you, Sylvia, can you share more about whether or not, since the Justice 40, the question is, can the Justice 40 covered element enable us to actually prevent the awards of any of these grants or loans from happening at all?
I don't think they can directly, but well, I think one issue with Justice 40 is, in general, it doesn't give you the ability to like sue and stop things, but it mostly provides kind of political leverage. So I think one reason or one way to think of it is kind of throwing sand in the gears and slowing down the process. So I think yeah, I think that's an effective way to kind of resist those types of developments, because you can kind of run out the clock and make it more expensive and difficult for the developers to make it happen.
Thanks for sharing that. And then another question for you, Arjun. Is there any way to adapt the existing CO2 scrubbing to also grab the methane? And if so, how much extra would that cost in time, energy, money?
I don't think so. As I said, the existing scrubbing technology with amine solutions is actually used to separate carbon dioxide from methane in natural gas production. So the methane goes right through the amine, and then you get pure methane on pretty much 96% methane on the other side, and other hydrocarbons. But there are other ways of methane destruction doesn't follow the same process and path as carbon capture and sequestration. Methane is eaten by bacteria. So if you cultivate the right plants that bacteria like, they will gobble up methane from the air. Certain kinds of nitrogen fertilizer actually inhibit methane-eating bacteria, methanotropic bacteria, they're called. In the atmosphere, methane has a short lifetime because it's destroyed by something called the hydroxyl radical. And so when you reduce methane emissions, the hydroxyl radical works on the rest of the methane faster. You're actually reducing the lifetime of methane in the atmosphere. So it has just as a negative effect in terms of reinforcing warming, it also will have a positive effect in terms of reinforcing mitigation if you reduce methane emissions. And then, of course, there's a possibility of generating hydroxyl radicals. That, of course, is kind of like atmosphere engineering, and we should approach it much more cautiously. But there are people looking at the pluses and minuses of doing that. It's more nature-based in that we're mimicking nature. So we have to attack methane reduction in a very different way. We know how to do it because Mother Nature is showing us all the time. And the first thing to do is to reduce emissions and then, encourage Mother Nature a little bit along the way, like with methanotrope.
Awesome. Thank you for sharing that. And then for you, Sylvia, given that this technology will be deployed in industrial areas, how should cumulative impact be considered?
Yeah, I think this is a really important question, and I don't think there is a very good existing framework for it at the federal level. I think this kind of goes to the current debate that's happening in Congress around permitting reform and the efforts to gut NEPA, the National Environmental Policy Act. I think I think we need to just keep telling the decision makers that cumulative impacts are not being accounted for in these permitting and siting decisions, and they need to be. And this is also implicated in the conversation around like the transport of CO2 and pipelines, as well as other kinds of pipelines that are being developed and discussed, like for hydrogen, as well as for like energy, like electricity transmission. So basically what I want to say is that cumulative impacts are not effectively part of the law and policy currently, and we really need to get it to be incorporated. Yeah, so I'll just stop there.
Okay, thank you. And then Arjun, another question for you. Proponents of CCS claim that carbon capture technology will remove air pollutants and therefore solve air pollution issues in EJ communities. How accurate is this claim?
It's not something that I've studied quantitatively. I think in some scrubbing technologies, yes, air pollution, sulfur dioxide will be reduced, for example, from coal-fired power plants. I can't give you numbers, I'm sorry. I will give some numbers to Taylor about this. But as I've said, some CCS and natural gas power plants, when you use amine solutions, you actually are increasing nitrogen oxide pollution. You're increasing nitrate pollution of the water. So I think the main object of CCS should be achieved on the carbon side before we can talk about collateral benefits. And as I've said, the main objective is not achieved if you do CCS. You burn coal or natural gas in a power plant, make hydrogen with it. You're not achieving your climate objectives. You're wasting a lot of money, and that money could be better used to. Let me give you an example. It costs about $30 a megawatt hour to do CCS with a natural gas power plant, and roughly twice that much to do with a coal-fired power plant. You can build a whole solar plant just for the cost of CCS. So, and that, that's in addition to the cost of coal and power and all that. So it's much more efficient to reduce fossil fuel consumption than to try to fix it once you've burned it. So the pollutant question I will answer. I'm not trying to escape it. I just don't have a good number for you right now.
Awesome. Thank you, Arjun. We have a ton of questions left. We are running out of time. So I think it would be best if we'll gather these questions and use them to help inform the other resources that we develop and include some of the answers in our follow-up materials. But I don't want to go over and take too much more of your time from today. I do want to thank Sylvia and Arjun for spending time and teaching us all this. I'd like to end on one question for the both of you. If you could summarize in a short little sentence from your view why you think CCS is a problem for environmental justice, or if there's something else that you want to leave us with, feel free to do that. So we can start with you, Sylvia.
My short sentence is it's not a good use of our time and money. I'll pass it to Arjun.
My short answer is primarily when used for natural gas, hydrogen, all that, it's not accomplishing your climate objectives. And we've got a climate problem we're trying to solve. So we need to get with it and solve it instead of trying to basically perpetuate the fossil fuel industry by spending lots of money.
Great. Great job, both of you. Those are great short sentences. Awesome. Well, thank you everyone for attending. I just dropped the link to our post-event survey in the chat, so feel free to fill that out. If there's other questions you have, you can use that survey to put them there, or you can email me, and my email is on the slide. You can stay up to date with our work on our website and follow us on social media. As mentioned, I will be sending out the recording and the slides by the end of this week, so stay tuned for that. And thank you again, Sylvia and Arjun, and I hope you all have a great rest of your day. Thank you. Bye.